John here. Let's add the code that we need to run a printer to our Retro BIOS here. Okay, so let's first do this and see what's changed. So I haven't committed any of the code yet. I just put this together, ran a quick test. I think we're good. I modified the Retro ASM file, which is where our BIOS source code is. And for whatever reason, I never created the Retro BIOS official driver printer support routines like I did all the other stuff for the SPI and the SD card and stuff like that from the code that I already discussed when we were testing all the peripherals and stuff on our Retro board. So let's have a quick review of this because I changed it a little bit. I changed a lot of these. I tweaked them a little bit because the test code was not identical or inconvenient, I can say, when trying to connect it to the CPM BIOS. It has a little bit different needs than what we were just playing around with. Okay, so as I showed earlier, this is for my Epson RX80 printer and my DEC printer 1 printer as well. If you happen to find a DEC printer, anything like the one I have that has a parallel interface on it, I don't know if I mentioned it. I don't think I did in the earlier video. I actually modified the electronics in that printer some 35 years ago before it was an antique. Right? I'm sorry. It turns out it's easy to undo if I really wanted to. I piggybacked a chip inside on its motherboard because electrically the parallel interface on the DEC printer 1 is identical to Centronics except for one signal is inverted, and I wanted to be able to plug it into my Altos and my IBM PC and stuff like that back in the day. So I made it electrically compatible with the IBM slash Centronics parallel port. I'm just saying, so don't just expect this to work if you happen to have one of those. You can make it work by tweaking the BIOS and inverting the signal yourself. I believe it was the strobe line or something like that that needed to be active high instead of low or whatever. Anyway, if you're really interested in that, I can show you what to do. Okay, so what are we doing here? We have to initialize our printer. I discussed this before. The bottom line is to simply make sure that the strobe signal is high, which is false on the Centronics slash IBM PC parallel port interface. Okay, and we need to save that in our cache and write it out to the general purpose output port, which, if you recall, is a latch on the Retro board here, and it's the signal right there that we're talking about. We need to make sure that that is not active so that we're not, accidentally sending data to our printer when we don't want to. So that's all we do to initialize this thing. If we ever want to know if the printer is ready or not, okay, the BIOS is going to call this subroutine here. And this is a slight variation of the one I showed you before to make it compatible with the needs of the BIOS. So what are we going to do? We're going to read from our GPIO input port. We're going to end mask off the busy bit. And what do we got here? If it's the busy bit is low, because busy, I guess, is an active high signal on the cable, right? Then we know it must be ready. Okay, so we branch down here. If it is in fact ready, and by decrementing A by 1, since we know A is 0 to get here in the first place, it changes A to an FF, which is what the BIOS is going to want to see reported back if the printer is ready. If it's not ready, it wants me to send back a 0 in the accumulator, and the easiest way to zero it out is like that, okay? No big deal, slight variation. This one's a little different, okay? If you want to print a character from the C register, right? Well, first of all, let's ignore this for a minute and look down here, okay? The way I went over this before, this is identical to the way it worked in the system test video, all right? So we don't have to talk about this code down here at all. It's just rubber stamp copy from the diagnostic code we did earlier. So here's the problem. If your printer is not plugged into the cable, then what happens to the signals on this connector here? Okay, well, it turns out the input, the status signals, if you go over here, are connected up to our general purpose input port here, right, with this LS244 on it. They're all pulled high right here. Now, honestly, the obsessive side of me, I'm very upset. Some of these signals, I put a bar on this one. It's not supposed to have a bar on it. I think the error is supposed to have at some point, I apologize. At some point, maybe I'll come up with a revision to the schematic that it will not modify the PC board at all, where I'll correct some of these signal names that have the wrong bars on top. Okay. Busy is active high. Error, I believe, is active low. What happens is, if busy is active high, and this is the key, and we pull it up over here, and no one plugs in a printer, the thing is going to look busy forever. So if you go to print something, and you do what the BIOS tells you to do, and that is to wait for it to become available down here, wait for it to become non-busy, and wait forever for that to happen. And once it becomes not busy, you go ahead and print the character that it asks you to do. You know, you're going to seize up your entire operating system in this endless loop right here. This was a classic problem back in the day. It's a problem with the PC as well. In fact, it got to the point where there were companies that used to sell a dummy printer connector that you could plug into the parallel port that would make it pretend like the printer is actually plugged in, and there was one there and it was never busy, so that if you ever printed something, it would simply discard the data, so you wouldn't seize up your entire machine. All right? So this was just poorly designed, okay? Now, here's the thing. If you look at what the signals are supposed to be, it turns out that when the paper is empty, all right, let's go back over here and look and see what's going on here. When the paper is empty, this will be high. And the specification says that when the paper is empty, the error status should also be active. And like a dingus, I forgot to put a bar on here. So this is a little not super easy to understand given this the way I've named these signals here. But if when the paper is empty, this is supposed to be a high, and whenever the paper is empty, the error signal is supposed to also then be low at the same time. We can then logically reason out that if every single printer status at the same time is high, what we have is a completely illegal, unacceptable situation, because it's never supposed to be in that state. Yes, there could be some transitions over the course of time where during the changing of states and things, there could be a moment where we could go ahead and grab a snapshot image of what's on the cable, and maybe we could see all these high at the same time. But they certainly aren't going to stay that way, okay? And you could improve this, is my point, but I'm going to go with it like this. Here's the deal. Before we go and simply blindly run the wait and print routine that we already talked about some weeks earlier, I'm going to do this. I'm going to read the status port, and then I'm going to check to see if every single printer line signal is high all at the same time, which is what I'm doing here. Read it in and with this, therefore I'm only looking at these bits. All the other bits are 0. Then compare it to that AND mask. If every one of these is high, then I've got a crummy situation. Just throw it away and go on my merry way. Right? This will save you the expense of going out and buying one of those dummy printer dongle thingies. Okay? So this is the big leap here from the system test code earlier. All right? And yes, Google it. That was a thing back in the day. Let's do a git diff now on this file here. Here's the only changes I made to the entire BIOS source code. After I initialize my console in the cold boot code, I'm going to initialize the list device. Okay? And I'm going to then replace the finish me comments and the dummy implementation for the printer status and the list down here, and all I'm going to do is tail call into the driver that we just did. All right. So to initialize it, I'm going to just call the init code that you saw in there and return. And then I'm going to, for the printing, I'm going to just go into the routine we just looked at with the check to see if it's, you know, an illegal state and throw it away. Otherwise, print it. And then if you want to know the printer status, I'm going to just use the printer status routine down here. Okay. And of course, we need to include that in addition to everything else in our BIOS. Once that's in their place, we are ready to go. In usual, burn it onto the SD card and move it into our retro board and press reset. Wait for it to boot up. And so far, the only code that would have run at this point that we added would be the initialization code. Okay. Now, make sure everything works. Okay, we're good. Now, on CP/M, if you're not used to this, what happens is if you hit Control P, what it will do is it will toggle inside the CCP. It'll toggle a bit that it will use to echo everything it ever prints on our terminal here. It will try to print it on the printer at the same time. If you hit it again, if you hit Control P a second time, it'll toggle it back off. Now, this is one of the annoying things about CP/M. It provides you absolutely no clue whatsoever whether the print toggle is set or not at any given time. So if you accidentally hit Control P and you don't have a printer and your BIOS isn't written like the one I just wrote, you just seized up your entire operating system. The only way out of it is to hit a front button reset. Okay? That's a little annoying. Now, I'm going to hit Control P and type directory, and we can see it's not seized up, and you don't hear the printer running in the background because it's not plugged in. So that verifies that the dummy check that there's no printer connected does in fact work correctly without seizing up my operating system. Okay, so this is a wonderful feature, if I say so myself. So let's move on to the next giant flaw in the design of how the PC parallel printer port works. And while it's nice that this thing will not seize up if the printer is not connected, which, I mean, let's face it, most retro boards won't have a printer connected. If that really is the case, you're never going to use it. I would just comment out the list routines and put the stubs back in there. But if you do hook it up and you do run this code and you don't hook up a printer at all, you'll be fine. Whether it's printing or not, you'd never really know, and all the data will be discarded, and you will not seize up your OS. On the other hand, if you do have a printer and you do plug it in and you power it off, 9 times out of 10, what will happen is all the electrical signals will pull down all these status inputs. And at which point they're not all ones anymore, they're all zeros. Okay? Now, I suppose we could also add some check code in there to ask if every single one of these is a zero, also discard the data. Because, I mean, if you're, what happens there? Stat, what is that thing? Now, according to the doc for the Epson RX80, this pin here is just pulled high with a resistor, which means if the power's off, it'll actually pull it low. This might be a worthy candidate to use to determine whether or not you should try to print your data. You know, if stat is low, maybe we should throw the data away. All right? Please discuss. Let me know in the comments below this video. What do we want to do if you actually have a printer and we want to use, you know, what logic should we use to throw the data away? I suspect every status low is good a unusual state to just throw it away, as is the every status high situation. Whatever. Yeah, I'm just saying, it's always been a problem for a lot of people. especially the people that don't have any ability whatsoever to hack their own BIOS or something like that and tweak it for their own particular printer. Anyway, so let's go ahead and plug a printer in. I'll show you what I mean. I'll plug my printer in now with the power off, and we'll watch this thing seize. I will then turn the power on, and it will then wake up because it'll simply be stuck in that loop, right? Okay, so here we go. Printer is powered off and connected. All right, to sanity check things, let's do a directory here. It printed on the screen. I hit Control P right now, and then type directory, dir, and hit enter on there, and you'll see it's stuck. Okay, let's go ahead and power the printer up, because right now I can't do anything. I'm stuck, right? And surprise, surprise, it's not working. So this is the problem with the seized up operating system, right? Hit Control P again, we're back to normal. Hit Control P in the directory while the printer is connected and hit enter. And you can clearly hear it running in the background. Printing out the directory. All right. So one way to print things on your printer was to use this Control P method. And that's fine if you really wanted to, print the output of a command, like, what you do in Unix or something, using a redirect command, like, something, and then you use it to pipe into LPR or something like that. That's the similar sort of thing you get here with, the Control P type of thing. If you didn't want to, see, the output to the console and you're typing and the prompt and all that, you could also do things like pip has the peripheral interchange program, right? You could say printer equals, and then you give it like a file name like readme. LPT equals readme means take the contents of that file, treat it as text, which means if it ever sees a Control Z in there, which is the end of file character in CP/M, it'll stop sending characters to the device, the LPT device, right? So this is how you would print a file without printing it on the screen. As you can clearly hear in the background, it's printing the README file. And when pip ends, it did a warm boot. That's why it hesitated here when the printing was done. So this is how you'd print out most of your files, right? So if we wanted a hard copy of the the MDS 500 assembly listing here, we could first look at it on our screen if you wanted to, right? And this is from the alteration guide. If you wanted a hard copy of that, you just pip this thing out to your printer, okay? A very common thing to run to your printer would have been something like this. If you say stat star.star, what you've seen this before, it tells you about the files on your disk and how many bytes and how big they are, okay? And you'll notice that I'm making enormous use of this scroll bar in this window here, which you don't have back in the old 25 by 80 days. Honestly, I don't know how I ever got by. I really don't. I suppose the big benefit of those days is no one had 115.2. I mean, you were lucky to have 9600 baud, and quite often you'd have your 48 and 1200 baud type of thing going on. And point is, everything took so long to print on the screen, you didn't necessarily need you didn't need a pager, you didn't need the scroll bars or anything else, just because everything took an eternity anyhow. If you were awake at the end of the time waiting for it to finish printing out, then at least you will have seen it while it was being printed, is my point. Anyway, so a very common thing to do is hit Control P, type stat star.star like this, and hit enter. And the reason you would do this is because you quite often end up with, many floppy disks if you had anything going on with your computer. And, unless you had 100 drives, you would never be able to just conjure up a directory listing of those disks. So what you would do is you print this thing out like this with a Control P and a stat like that. You take the paper off your printer and stick it in your floppy disk container in your stack of floppies, so that you could tell what's on those disks without having to put the thing into the drive and type dir and scan through 400 floppies looking for the one file that you want. Of course, the downside there was, as soon as you changed anything, you'd have to reprint your listing and stuff like that. So once in a while, they'd get out of date. But that's okay, too. It's just the way things were back in those days, all right? A printer was your friend, you know, and your whole world was just this, not even this big. I think, what is the size of this terminal right now? This is 26 lines. Woohoo, I'm living high on the hog here. I've got a whole extra line of text on this compared to what you'd normally see in a terminal, right? So, yeah, things, you know, printers were a big deal, all right? That's why it was fundamental. It was absolutely part of the core roots of the CPM and its BIOS. Anyway, so that's all it really takes. Printer's easy. Thanks for watching. I'll see you next time.